Okay, I'm going to presentation of our term project. I think my presentation will be finished in a very short time, so please focus on. Okay. Yep. So our term project proposal is about visualizing classification decision of a neural network. So our team members are Jusong, Tuan, and Usong. Okay, let me start the presentation of introduction. As you know, nowadays we live in the age of deep learning, and deep learning brings high performance, but there are always pros and cons. In other words, it gives us high performance, but it has low explanation capability. For example, even though it has high performance, we cannot easily make decision in a specific area like medicine, finance, or automatic driving car, because one decision could lead critical result in this area. Therefore, nowadays, needs for explorable AI are increasing. So, explainable AI program was launched to explain AI's decision to human users, especially in DARPA. Here is it done today. There are several approaches to explain what neural network do. So there are many approaches such as sensitive analysis and projection of activations, LIME, and LRP things. Sensitivity analysis is about gradient approach. In order to explain decisions, it calculates gradient of output value corresponding to each input pixel. It is often used as a baseline. And projection of last hidden layer activation is another approach. It is used to see distribution of output activation value in last hidden layer with PCA or TSNE. And LIME was proposed method in KDD. It only remain pixel that is related to decision. And last one is layer-wise relevance propagation, and it is activation-based method. It defines output value as a relevance and leaves it distributed to the input layer. So to summarize, sensitivity analysis is related to gradient approach, and LRP is related to activation value based approach. So this is our approach and our milestone. So we divide into two steps. We are going to implement sensitivity analysis and PRA and LIME approach until May 20. And we also have a plan to implement attention and LRP to compare with each other. And we are going to improve this method, and that is our approach and our milestone. And this is end of our proposal.
so let's do some peer evaluation. Although I didn't plan it, but yeah, please write your evaluation as a yeah, in terms of so you will have, yeah, you will assign or determine the overall score all from 1 through 5, the scale of 1 through 5, and then overall score, motivation, and presentation clarity, which means how clear the plan is, or how detailed or concrete the plan, yeah, the current plan or proposal is. And then the motivation is like how convinced you are, yeah, when listening to this proposal. I mean, how much you agree with this kind of a project. Then originality. So how unique the approach is. Okay? And then what else? Do you guys? Okay. Is there any other thing? Let me quickly check the website to see if we have anything to add. Let's see. Clarity, significance, correctness. Yeah, correctness is about how accurate the derivation or proof is. So we don't consider this at the time of this project proposal stage. Yeah, the significance, yeah, it's about maybe some uniqueness or novelty, I think. And then clarity. Motivation and clarity. Okay. Okay, so please, then maybe comments. Okay. Yeah, so please record your score for each of the other teams. You don't need to evaluate your own team. And then, yeah, I will send the website where you can move your handwritten scores into some web-based form, like a Google Forms or any other similar types. Okay. And then, do you want to add something in order to improve these aspects? No. 조 이름이요? 네, 그냥 1번, 2번 뭐 그냥 타이틀 키워드를 좀 적어줄게요. 1번 네. 아니면 이제 1번 뭐 윤주성 학생, 네, 윤주성 학생 이렇게. 아니면 그냥 넘버로 이렇게 하고, 네, 하나 빼먹지 않고, 네, 밀리지 않고 잘 할 수 있도록. 네. So again, the scale of the score for each item is from 1 to 5, which means 5 corresponding to the best score and 1 as worst. Okay, and then maybe 3 as like neutral. Okay, and then did you finish the evaluation of the first presentation? If you need a little more time, please let me know. Are you done for the first team? 녹화요? 녹화하고 있을 거예요, 아마. 네. So yeah, assuming as long as you agree with the recording of your proposal, so it's completely recorded, and then later I'll post this on the YouTube just as a not public one. Okay. Okay, then the next theme or presentation is this.
그냥 이렇게 넘기면 되나요? 이거 눌러서 넘기면 되나요?
스페이스나 화살표.
네, 알겠습니다. Well, good afternoon. Our team's project is to build a pronunciation evaluation system using automatic speech recognition technique. And I'm going to present what we're going to build and why we're going to build it and how we're going to do it. So, of course, there are a lot of available systems for evaluating English pronunciations or French pronunciations. But the biggest problem of those current systems is they don't really rely on what you actually said, meaning that they don't use speech recognition technique. Instead, they use a overall pitch contour or the intensity of energy of a speech. So it's not really relevant. And another drawback is the way they give the feedback to the learner. Most of them uses a pass or fail feedback system, and it is apparently not enough for the learner to learn what is wrong with their speech, right? So we want to overcome these challenges and build a better system. So these are the virtual screenshots of our product yet to be made. And first of all, the learner chooses a sentence to read using this drop-down bar and press the speaker button to listen to the native speakers reading the identical sentence and use it as a reference. And by pressing this record button, they read the sentence, and in real time, the phones and the words that are recognized using our ASR system will appear on the screen. And next, when you press the score button, each phone of the sentence will be graded as this percentage grade. So we're going to use barplot for this. So the learner can be provided with more specific and detailed feedback, which is much more helpful. And in addition to that, we're going to draw the distance between the phones, both pronounced by the native speaker and the learner. So the learner can compare how the phones that he or she pronounced are clustered to each other and how closely they are clustered, and compare it to the native speaker's one. And how are we going to do it? As for our ASR model, we prepared a 360-hour-long clean read speech of Native American speakers. And the model will be trained with a GMM HMM algorithm. And the toolkit that we're going to use is CalB, which is written in C++. And for grading metric, the ASR system, in the decoding step, it outputs log likelihood of each phone pronounced. So we're going to use it as for grading. We're going to use it for grading. And the metric is the score of each phone will be calculated by subtracting the phone log likelihood of native speaker from the learners. And to plot the distance between phones, we're going to use TSNE algorithm because we thought it'll be relevant, because each phone will have 39-dimension acoustic feature, and it'll be reduced to 2 dimension in the beginning of TSNE algorithm. And then what we're interested in is the local and global distance between the phone. So we thought that this is very helpful for the visualization of this phone cluster. So this is all. If you have any questions, please feel free to ask. And thank you for listening.
Good afternoon, everyone. I'm Minjae Choi, and I'll be giving this short proposal on behalf of Taewoon and Jisoo, our team members. Okay, our topic is visual analysis of diseases and depression levels of OHC users. Before I get specific, I'll first give you a brief explanation of what OHC stands for. Okay, OHC is an online health community, and there are many online health communities in the US. That's because they've got so expensive medical bills, so it takes thousands of dollars just to get diagnosed and get treated. So many people stick instead to online health communities such as Patients and Like Me, WebMD, and even online communities such as Reddit can also be seen as an OHC. Well, there are problems in OHCs, and is that there is this imbalance between the number of moderators, that's doctors who work inside these communities, and the patients themselves. There are so many patients that the doctors cannot see each and all of the patients' requests, and they can't find which patients are more urgent and have different needs. So this is where we kind of stand in this position. We try to make a visualization tool that describes the trends of the topics and emotions of what different patients have, and then so that the doctors and moderators can use them to pinpoint which patients need the most immediate and urgent needs. Okay, so since this is kind of vague, I'll give you a short expression of what it might look like. So we're trying to get all kinds of threads of a specific patient in this timeline base. And you can see the different timelines situated here, and then we've got different topics which will be obtained through NMF-based topic modeling, which was covered in this class. So as you can see, the first topic mostly consists of health, nutrition, blood pressure, whereas the second topic is more about depression, sad, depressed, dying. And then you also see like the different colors, which, well, there seems to be a mistake in the color system. It's supposed to be green to yellow to red, but then there's these blues. So we see that more green and blue colors represent more positive threats, while the red ones and the orange ones are more negative and thus dangerous threats. So our system kind of tries to locate all these threats in a chronological order, and then by clicking on some kind of individual text, then we could see displays these kinds of threats. And from here we can see the positive and negative reviews, and then this in single, it just shows like how one user feels and how his mood changes over time. But then combine this with many different users, and this is kind of different visualization plot, but then it's just here to show you about how the data amasses into a large level. And so like looking at this, then we can see like which patients are more urgent and less urgent. And then from here, the doctors can individually click each patient to get more precise knowledge about he or she and what kind of treatments can be bestowed. So this is our process flow, and we'll be mainly using libraries from Python and maybe, well, not included in here, but if we are trying, and we also have plans for sticking to web visualization, and in that case, we might also use d3.javascript as well. Okay, so that was kind of like the end of my presentation. And oh, well, this is what I forgot. Like, this is like showing individual threads by clicking, and then that under here we'll display the individual posts that was most recently uploaded, so that people can get a more clearer glimpse of how his or her mood is changing. Okay, that was the end of my presentation. Are there any questions?
Any questions? So what are these axes? The meaning of these axes?
Oh, well, they might differ, but in this, you mean this plot?
Yes. And
Well,
also in the previous slide.
Okay. As for the previous slide, the x-axis is obviously going to stand for time. And then on the y-axis, we will try to just display different patients. So there won't be any kind of prevalence or order on these axes. But then maybe if they're displayed in the line, then we can see like how there are positive or negative trends among the scores. We will try many visualizations, and that's why we did not include one specific example. But one basic example could be like by measuring positivity or negativity scores based on sentiment analysis. So like when you got higher scores for patient A, then his thread will be located at the top of the graph. But if there's patient B who's mainly got lower scores, then his thread will be at the lowest bottom of the graph. But then if his conditions improve over time, then the line will go upwards.
So you talked also about the next slide, right?
Yes, so they kind of intertwined, and yes, but then there were so many graphs that we were thinking of, so we couldn't implement all of them. But some of them were also included in the proposal that we submitted. So if you plan to upload those as well, then others could also get a clearer view of what we're thinking of.
Any other questions? Okay, thanks.
Thank you.
Hi, I'm Juno, the presenter of our team, and our team includes Minseok and Sonbo. First of all, I'm gonna tell you the overview of our system. Our system is named textile. It means multi-level tile-based spatial temporal visual analytics for event detection via exclusive topic modeling on social media. It's a very long title, and this is our system. This is tile-based map. So in each tile, the topic keywords is showing. The keywords are computed based on the topic modeling system, and each color represent the topic indices, and the word size represent the word frequencies. So if you click the certain keyword, the frequency over time will represent, and also the detailed tweets include that selected keyword will also represent it. And if you click the tile, the novelty scores over time will represent. The novelty scores represent how different this tile is when compared to neighboring tiles. And also the users can change the parameters such as exclusiveness or time or word count or cluster count. So why do we need this system? This example shows the tiles of New York City at July 2013. The left two tiles are topic keywords at exclusiveness value 0, and right two tiles are topic keywords at exclusiveness value at 5. At July 2013, there was some event. The people who named George Zimmerman, who killed the African American. So, and he was proved to not guilty. So many people talking about Zimmerman. So when exclusiveness is 0, the common topic will appear, such as Zimmerman, George Zimmerman, black, white people. However, at the same time, there was a triathlon. So if we set exclusiveness to 5, we can find keywords such as the finish of triathlon. So by using this system, the user can find some exclusiveness topic, which is not common but important. Actually, we already submit the first version of our system to IEEE BIS, but however, we will gonna revise our system, and we plan to resubmit to TBCG journal. So what we're gonna do is, first of all, we will change our algorithm to speed boost our computation time. So we will use parallel computing to get topic modeling, and we will gonna use prefetching, which is we will predict the user's next movement. So we will pre-compute the topics, and also we will gonna improve our temporal analytic visualization by using dim reverse style, so we can show the topic evolution over time. Also, we will change our novelty score calculation, so the user can find more easily which topic is abnormal. So it helps users to find the abnormal event. Is there any question?
Any questions? Okay, I'll add another rule during our session. So yeah, each person should ask at least one question. Okay. It's a quite dynamic class, but
So is there any function to
Can you repeat one more time?
So is there any function to select the regions or maybe?
Oh, he will answer the question.
Oh, I didn't quite understand the question. Can you repeat for me?
So is there any function to select the regions or area?
What do you mean by selecting the regions or
그러니까 그 지역을 선택할 수 있는지.
selecting the regions? Well, we're trying to program our system in a way that the users can kind of select the tiles or the places where they're interested in. But what you're asking is probably, at first, we will kind of show the overview of the topics of the map so that the users can kind of find out by themselves where, in which place, the user might be interested in. Or probably we would also be showing some kind of heat maps to help users to see which place is kind of abnormal or which place might be interesting. Okay.
Any other questions? Okay, thank you very much.
Okay, hello everyone. Our project is called Hearthstone Data Visualization for In-Game Robo-Advisor. So I'm thinking that most of you guys know what Hearthstone is. It's a strategy card game developed by Blizzard, and we thought maybe we could visualize the data we get from Hearthstone to make the game much better for the players. So yeah, straight to the goal of the project. Our goal of the project is an automated advisor the player can use in-game, not after game. The goal is to use in-game. So we'll offer players lots of insight by calculating possibilities and giving advices using dynamic visualization technique. So with a easy to understand design. So seems like an image is missing. So that is the log data we can mine from Hearthstone. And this is the Hearthstone's, one of the deck tracker is a third-party program. And we are going to mix those styles and create a new program that visualizes such data. So, okay. I know that some players here have been using Hearthstone and using a program called a deck tracker. So that is the in-game image of Hearthstone, and on the right side there is a small bar which is called a deck tracker. It's a third-party program that gets the API data from Hearthstone and visualize the deck into a whole image, and it shows the player what kind of card the player draws, or what kind of card the player has in hand, or what is now gone. So, but yeah, it's a very useful program that everybody uses, but there is a limitation to the program. The limitation is that the program only shows the player what the player has and what the player knows. It does not calculate anything for the player. So, mixing with the goal of our project, we want more than this. We want to add more visualized calculation and show it to the players, showing what kind of card the player just put on the ground and what kind of possibility the player can win in the next round, or how much the possibility of the player winning or losing will increase or decrease according to what kind of card the player uses. So this is how our project is going to be done. So we just said mid project goal. We don't have an exact date, but so mid of the project, we are going to use the Hearthstone API, which is provided by Blizzard, and we are going to record the game session, and game session as data in real time. So most of the programs the other companies use record the history after the game is done, and then calculate it, then show us the result. But we want to record the data in real time and calculate it in real time and show it to the player. Then we will structuralize the mined data, make it pre-process the data and make the data much more useful, and then analyze the data, put it in some algorithm and calculate it. And our final goal is to visualize the data in the most efficient form. So along with that, we will develop a user interface that fits with the Hearthstone game. And finally, we will develop a usable prototype that we can use. And this is our team member. I'm going to be in charge of data pre-processing and UI design. And another member, Uni Zhang, will do data processing with me, and she will do the algorithm implementation. And Sungdin Park will also do the data pre-processing and algorithm implementation. Okay.
Hello everyone, let's start the presentation. Our term project title is a unified visualization tool for array database DBAs and analysts. And our team member is Hyuk-Lee, is me, and Ms. Kim. I think most people are familiar with the relational database or spatial database, traditional database, but I think array database is unfamiliar thing. So I'll explain about the array database. Array database is a system using array data model, literally. So in traditional database, tuples are represented rows and columns. But so if data are multidimensional data, each dimension corresponds to column. So if, for example, in the case of two-dimensional map, its x-axis and y-axis exist in the map. So these axes corresponds to columns. So the tuples have some value and x-axis and y-axis value. So if we process this data to get information in this tuple, you read the tuple and check the x-axis and y-axis and the value. So it's very inefficient to multidimensional data. So in order to benefit from this multidimensional data, so array data model is adopted in array database. There are several kinds of array databases, is SciDB or TileDB and Rastama. But we will use the SciDB because it's the most popular databases. Array database can be used in various applications in scientific area. Scientific data with inherent dimensionality, such as imagery with pixels or observational data in coordinate system like astrophotography, and temporal data. In temporal sequential data, time is also dimension, so it is very high dimension. So linear algebra, machine learning, and other complex analytics also can be processed in SciDB. Arrays are the natural way to store data for linear algebra operation, which saves time moving, organizing, and preparing data for matrix math. So analysts can efficient and effectively analyze their large volume of multidimensional in array database. Now that we have outlined the array database system, as you mentioned in the title, we will develop a unified visualization tool. Most of the relational database systems have GUI tool,
for managing database and bringing the data store in, such as pgadmin in PostgreSQL or MySQL Workbench for MySQL. But there is no GUI tool for array databases, IDB, or any array database. Array database is the next paradigm database management system, so there is not yet developed the GUI tool. Actually, many kinds of GUI tool for multidimensional data are developed. However, the GUI tool for SciDB should be able to easily analyze the array data and visualize the result of the query process. So it is. So we will develop a GUI tool for SciDB. In our project, we propose a unified visualization tool for array database. Unified has two meanings. First, the tool is for both DBAs and analysts. For DBA, the tool needs to be able to manage the data well. And for the analyst, it needs to be able to visualize well. And second, the user not only view the raw data, but also can execute the various queries and get the result. So we will develop GUI tool like this form. I'll finish presentation and questions.
Question? So in the previous slide, is this snapshot from some existing tool or?
Yeah, it's a Prisma, multidimensional data GUI tool. It's only showing raw data.
The Prisma is not for array database. It's not related to database previously.
Yeah, a little bit related, but in databases, the query result and query processing is needed, but it is only for multidimensional data. So
It's not integrated with the query capabilities.
yes, it's not related to database. It's only for data.
Any other questions?
So my name is Iunan and our team is with Kim Sun-bin and Lee Hyun-jo. So we will gonna our topic is about rule visualization tool for training artificial neural network. So it's a little bit similar to the first one presentation because we are on the same lab. Anyway, so what we are gonna do is implement a tool for extract rule from the deep learning, but in sorry, I didn't prepare that much. Anyway, so we are gonna extract rule from the simple DNN with I'm not sure, but some layers not very deep. So why this is important is that as he said, the deep learning is very powerful. It has 95% to I mean 95 overall 95% accuracies, but there are some chance of miss the right value. So in critical domain, it is very problem. Like think about AlphaGo. In AlphaGo, the AlphaGo plays every time weird thing that pros don't understand. But for first and second and third, it was a good uh, a good action that AlphaGo does that others don't understand. But at fourth match, what he does was really bad decision. So AlphaGo lost the game. So when we use to deep learning to some decision, then it is very important to know that why the deep learning decide in this way. So we called it the rule that what the deep learning understand, and the rule is the knowledge that deep learning really trained. So there exist some algorithms, but they are kind of really old. They are kind of old, about 20 years ago, because before Hinton, the artificial neural network research kind of that the major research that time was minor research. So rule extraction research was not that in depth. So we will gonna visualize what the really ANN trained. Currently, there is algorithms that show in the sentence form, but if the rule is become more complex and layer is deeper and hidden node is bigger, then the rule become more and more complex. Like there is what kind of 100 input node and there is output, then it make really hard to understand the rule at a glance. So for that, visualizing is a little bit helpful to human to understand what the ANN really trained. So our implementation is currently we are planning to based on the KT algorithm. The KT algorithm is the most basic rule extraction algorithm for ANN. And so what we are going to visualize is the edges and weights that really affect to the decision what neural net make. So I better put some image, but it's hard to explain. What we are going to do is first we have to build the ANN training models. Thankfully, there is a lot of libraries that we can use like TensorFlow or PyTorch. So we are gonna implement on Python. So I think PyTorch is better for our implementation, but actually we didn't know that much of PyTorch, so I think we may gonna use TensorFlow. And then we have to visualize the simple ANN. So there is like in R, they are called library NNet. They visualize the ANN. So in ANN, it's kind of the NNet, long like this kind of form. So they visualize weight with the thick of the line. But actually, it isn't not in the rule form. They just show all the nodes with the weight, and they just show how much these nodes are affect to the hidden nodes. So so after that we are going to implement the KT algorithms, and also we have to visualize the KT algorithms. So I think it's kind of what we plan to do. So like the blue line, it is the positive effect to the rule, but the red line is negative effect to the rule. So so our final is like we can change some node number and layers number, and also we're going to show the process of how the rule extraction and the final result in the graph form. So I think this is what I prepared. So if you have a question, ask me.
questions. First one is what is the input and the output of the ANN?
Ah.
And I understand that you want to now extract some root from the ANN, then you want to interpret what the ANN do in your algorithm, right?
Yes.
And what kind of form of that rule
Ah,
will be?
So for KT algorithm, the rule form is like if-then rule. So if A and B and not C, then true. Or if not A and C, then false. It's kind of the rule that the KT algorithm extracts. But there is other algorithm extract that called M of N rules or fuzzy logic rules. So maybe if we have time, then we can make other algorithm to that. But at now we are planning to do KT algorithm only. And what was the first question? What is the input and output for ANN, not KT algorithm? Then input is for KT algorithm. The input is high feature that what not the low feature like image or what speech data, but the high feature that what human extract some feature like more humidity or temperature or kind of this thing.
So what kind of data set are you going to use?
I'm not sure now, but there was some data set that used in previous research, so I think we are going to use that kind of.
I didn't quite understand. Like, are you going to be visualizing the process of making the algorithm, or you're going to be visualizing the data, the kind of final output from?
I need to both. We are going to first show the process of the restriction, and second the result. So for the result, there are extract several rules, and for each rule, this kind of graph form will be changed because for each rule, some will be not affect to the then rule, and some will be affect. So we are gonna extract both for the process and the result in a graph form.
Any other question? So in your rule example, it sounds like you are handling binary input data. So A,
Yes.
not B, and something like that.
Yeah.
Assumes your input is binary.
Yes. For now, it's binary, but it can be implemented to the fuzzy logic. But now it's for binary.
Any other questions? Okay, thanks.
Hello everyone. I'm here to present our project of visualizing and understanding the generative adversarial networks. Our team members Yoonjae and Min Kim. And is there anyone who heard about the generative adversarial network, which is called the GAN? As you can see from the name, it is the generative model. Then what it generates the image in our system, and the image which is not in this real world. Then how it works? Basically the GAN is composed of the discriminator and the generator. The discriminator is the classification model which tells whether the image is the real or the fake. And the generator generates the image. Then I will explain in details. So the GAN first train the discriminator. So input is the real image and the fake image which is generated from the generator. And then the discriminator is trained to tell that if the real image is true or the fake image is false. And once the discriminator's parameter is updated by the gradient descent, then the generator comes out. So, and then the generator is trained with the discriminator, which is trained before. So, generator in here is trying to fake the. We know that the discriminator tells that the real image is real, but the fake image is false. But in this time, generator is trying to fake the discriminator. That means it should generate the image which looks real enough so that the discriminator says that fake image is real. That's how the generator is trained to produce the image which looks natural. Then, what kind of then to understand we know that how the GAN generates the image. So to easily understand the characteristic of the GAN and to check the quality of the image, we propose the visual analytics system about the GAN. So we use the TSNE to embed the random vector jet, which is used to generate the image to the space. We select the TSNE algorithm because it is the one of the state-of-art algorithm into embedding. And so that and the TSNE embeds the random vector G in the scatter platform, so that user can click the dots, which means the random vector G, and then the GAN calculate the image, the generated image right away, so that user can see that what the random vector is corresponds to the fake image. So here is our pipeline. So in advance, before the system, we need to train the GAN model using the PyTorch. And then we save the parameters. And then we also randomly generate the high-dimensional vector jet. And then on this system, we embed the jet using TSNE, and user can click the dots. And then the pre-trained GAN generate the fake image right away. Then what kind of motivation we can, what kind of understanding we can get from this visual analytics system? So we have we expect the user can understand the two characteristics of the GAN. The first idea is we expect that the generated similar image is located closely. So for example, the woman in the black hair are clustered closely, and on the other hand, the blondes located close to each other. And second idea is we can place some vector arithmetic of G, and we can visually realize the operation of the G. For example, we can expect that this cluster is means the man with the glass, and if we and then the random vector G minus random vector G of this man with the glass minus the man without the glass, and then plus the woman without the glass, then we expect that the woman with the glasses images of the woman with the glasses would locate here. So this is for our proposal, and thank you for listening. Is there any question?
The dots in there are basically random, right?
Yeah.
It's a random uniform distribution.
Yes.
Then,
Yeah.
don't you have to know what the generator generates before visualizing it?
Sorry?
Don't you have to know what that point can generate in order to visualize it?
I mean, what kind of image the random vector?
But in the pipeline, I saw that you first visualize the random vector, and
Yeah.
then if the user clicks on it, then
Yeah.
afterwards the pre-trained GAN generates the fake image. Right?
Yeah, that's right.
But if you're trying to cluster or like in the picture, if you want to color the points, don't you have to already know what the dot will generate?
Sorry. So actually, the labels would not be in our system because I just brought this scatter plot. And another thing is we trained with the real image, right? So that image would have some woman with or without the glasses, or the man with or without the glasses, and so we cannot expect what kind of the image will be from that the random vector G. But the one thing is random vector G is conditionally given to the model. So we expect that if the random vector G is similar, that means that they are closely located to each other. Then there will be the similar image that will be there.
마지막 페이지에서요.
네.
TSN에서 인베딩된 그 이미지 같은 경우에는 저렇게 벡터 형태가 아니, 벡터의 어떤 형태가 아니라 그 하이 디멘전에서의 그 데이터가 3D로 인베딩된 결과일 뿐인 건데 저렇게 벡터 형태로 그렇게 나온다는 것을 보여주겠다는 것을 그대로 못 들었을 수 있는데.
Firstly, we embed the random vector G, which is a high dimensional vector. And then we embed that random vector G into the 2D space. Right? And then using the high dimensional vector G, we generate the fake image. And the GAN shows that image on the scatter plot. So actually, we do not directly embed this image. Instead of that, we embed the high dimensional vector G, which can be embedded. Is that for your question?
그게 저렇게 예를 들어서 그 블레스에서 뭔가를 빼고 저런 연산이 된다는 말씀이시죠?
We expect that. 네. 기대하고 있어요. 그렇게 되길.
Which clustering has to be used? 어떤 클러스터링 쓸 거예요?
클러스터 안에
그러면 색깔은 어떻게 돼요?
아까 말했는데 색깔 안 가질 거예요. Another question?
So I have like a similar question to the previous student.
Yeah.
So it is without even considering GAN at all. So you are trying to just randomly generate just a random vector from uniform Gaussian distribution, and then try to visualize them using TSNE. So I'm not sure. I'm not sure how meaningful the visualization will be.
I said that there will be
It
no
will be just a visualization, TSN embedded visualization of just Gaussian random vectors. Right? So it will not potentially reveal any cluster structures or any outliers.
I guess then we need to we need to consider it a lot about the distribution of the random vector then.
It might be more meaningful if you can estimate C from the real image. So it's like an inverse function of generator when using the real image, and then you may be able to to find some meaningful structure about the real data manifold. In that case, those Z vectors corresponding to real images might reveal some clusters or some meaningful structures about the data. Any other questions? Okay, thank you very much. Okay, let's have a 10-minute break.
나한테
형이랑 길을 하겠다는 거 아니에요? 어제 물어봤는데 내일이 돼요. 꼭 적으신 준비가 요리 많아졌네. 몇 시간 준비 안 했다고 준비 안 한 시간이 많았구나. 두 시간만 머리 잡았구나. 좀 몇 개 정도 나왔어. 한 7개? 아무거나 아니야, 철봉 아니야. 프롤링 소스가 부동산 비동식 좀 준비해야 돼. 이거 내가 멀티플러스에서는 멀티 프로세싱도 이제 준비했어. 멀티 프로세싱 말고 그거를 워킹 사이즈, 그거 워킹 사이즈로 다른 싱크 시작을 그거는 지금 파이썬을 쓸 때 파이썬 이제 이거 메인 파일이나 이런 것을 크게 만드시면 거기서 이제 쪼개지는 거죠. 이한수 저항 이런 거. 빨리 좀 해봅시다. 우리 지금 수동을 좀 시켜야 돼서. 알고리즘은 내가 하시는 거 아니 이게 그걸 되게 작아. 2.1 안에 되는지 나 섞어 하기 싫어. 너무 어려워. 파이썬 인스톨레이션 포기하고 있어. 써보고 용역이가 64 망해가지고 감정 분석 기쁜 마음이 좋아요. 차라리 계정 키우고 선곡도 있고요.
Okay, let's continue. So yeah, we missed one presentation. So we'll continue with the summary. Okay, hello. I'm Sangyo, and I'll present about my project called Iwakun, which is a real-time visual analytic for interactive wave steering convolutional neural network. Actually, I didn't notice that this neural network topic is that popular. We already have 2 artificial neural net team and 1 GAN team, but Now mine is convolution neural net. So okay, before we get started in the details, please raise your hand if you don't know what CNN is. Oh, nobody? Well, okay. But I'll just explain what the CNN model is. Okay. If you look at the upper image, it kind of shows you the abstract form of convolution neural network. So what the model is trying to do is to determine whether the input image is classified into several classes. For instance, like bird, sunset, or dog, like or cat. You can see the image is a bird. So the model tries to find each probabilities for each class and trying to guess the class. And what I'm trying to do is to get better understanding of convolution neural network. Like the previous team said, deep learning models are usually considered as a black box. So it is not clear to understand the inner workings of the model. And like if you know the algorithms and the optimization steps, but the model itself contains a lot of parameters. Like for instance, like VisAnalytics contains like 10 millions to 100 millions or even billions of parameters. So I think we can say that by the model itself is a big data, and we need this kind of bigger analytic system to get to understand the model. And the next problem is model flexion. It is very important to set hyperparameters for the deep learning model, but currently what we are doing is just doing the random search to set the hyperparameters. And I don't think it's very scientific because it is dependent on the random values. So we like to visualize the deep learning model and see how we are going to work with the hyperparameters. Next training, like the model flexion, deep learning models are very highly dependent on weight initialization. And every time you retrain the model, you always get different results. So, and of course, we like to visualize that too. And lastly is the interaction. There are several convolution or several like visualization systems out there already, like TensorBoard from Google, but none of these visualization systems support interactive systems. Like, well, you can like change hyperparameters, but you need to retrain the model from scratch. So like, I think our project is the only interactive system that is publicly available. Okay, so next. So my solution is to upgrade our current system with Rivakun by adding novel interactions and visualizations. Actually, I've been working on this for quite a long time, and this is how it looks like. And this is the current version. So you have the network view, and here you can see the charts of the training status. So this is the convolution neural network model. So for the given input image, we pass it through the layers, and we get the final output values. So by just looking at this, we can see all the parameters. All the parameters are included in this network overview. And yeah, I'm using a data set called CIFAR10, which contains 50,000 training images and 10,000 images for testing. And we have 10 classes for the data set. So like, it is not clear to see what the image is about. It's a horse, and like, if this is a horse, then the last layer, the value becomes greater. And because it's an interactive system, you have options to interact with. Currently, we have these freezing features that you can actually freeze the layers and training only the layers that you selected. And this is like pause or play button, so you can leave it as this. So this means you're going to train the whole layers, or you can like click on it so you can pause the layer. And by doing so, we can actually reduce the training time because we only have to train the partial subset of the network. And like these are the charts. This is a loss chart and the accuracy, and this is the time interval for one epoch. And you can see the network structure view. And I don't have the image for this section. It's called invading view. So like others already mentioned, it can also have this invading view using TSNE, so you can get a TSNE view for these inner activations and for networks filter. Okay. So next, so what we're gonna do for this project is I'm going to first upgrade the current visualization system, and first I'll change the bar graph, which is this one, and to the stacked bar graph. Bar graph stacked by each class, and second, we have a scalability issue, so we're going to show only the nodes in which values are like certain threshold or limit the number of nodes and the activations as well. And by doing so, we used to use CIFAR10 dataset, but if you apply this feature, then we can use other datasets like ImageNet, which have thousands of classes. And also next is add more flexibility to TensorFlow model. As a backend, I'm using TensorFlow model. So, but it is a bit difficult to change the TensorFlow model because it's stick to the visualization system. So I'll add more flexibility to TensorFlow model to allow the users to change the model to like VisNet or Alex or VisNet kind of model. And for new features, I'll add new visualization chart to detail information about gradient values. Like CNN is among the most popular deep learning model, and many researchers are working on the gradient values. For instance, like shattered gradient problem is like one of the famous paper describing these kind of issues. Also, vanishing and exploding is very important to understand the issue. So I'll add new visualization. And next, I'm trying to extend the model to other computer vision tasks, like object localization. And if I have time, I'll try to implement the segmentation as well. Next is I'll add novel interactions, like I showed you before. Like we can freeze the model, but I'll add new interactions to like pruning or adding new filters or layers to the network. So like doing so, we can increase the model and get better accuracy or decrease the number of filters to make model smaller and like smaller to like fit in mobile environment or that kind of thing. So like my project goal is the last sentence is that I want to make a visualization system that really increase the model's performance by applying these kind of features. And and lastly, actually I have a Git repository for the previous version of this. So if you're interested in working neural net and like deep learning, then yeah, you might want to check out the GitHub. You can search by the same name, Ivakan. Okay, thank you. Any question? don't have many presentations at this point, so I encourage you to ask some questions.
And for the plan, I'm the only team member, so I'll do each of them within each week. Yeah.
No questions still?
Yes. Hello, I'm Yunaha, and I belong to Granular Language Process Lab. Let me begin by talking about mood visualization using learner activity data. First, what is mood? Mood stands for Basic Open Online Course Textbook. Mood like yes. Mood is similar to MOOC. You know MOOC? MOOC is represent site is Coursera. So MOOC typically the Coursera system consists of only feedback. So which is a limitation of accuracy profiling and feedback by the major of learners. So I explain MOOC. It is similar. MOOC is a test-based model where a large number of students can learn online. The biggest advantage of MOOC is that you can practice using the site without having any special program installed. So this is MOOC model, and it includes environment practice and conversation learner analytics, and it is matching city MOOC and yes, environment practice and matching comments. That is. So based on the MOOC model, there is a site called City MOOC, which actually applies the MOOC model to a real class course, computational thinking. It's City. The learner data store and this Python locally and City site include page activity and quiz locally and Python practice environment. So we use that site and we want this visualization. So we plan or show a star plot to visualization or aspect of a student's performance and efficiency and effectively. So we the red in the star plot symbolize the total amount of students' activity, and the yellow one is indicate the accuracy rate for each activity. So this can be used to identify a problem with students profiling or for dropout prediction and learning. Yes. So this is contribution and both sides visualization students overall learning activities, and on this basis, instructor can improve the learning efficiency of the students by being able to understand where the students are lacking and providing appropriate feedback. It also motivates students to raise their grades and help them maintain their willingness to learn. So we maybe in the future, in addition to this, we expect to be able to classify dropout learners who are not progressing in learning and provide feedback by email. My presentation is finished, and thanks for listening. Any question? Yes.
Can you use the students' information?
Information?
The data.
how can gathering 한국말로 답할게요. 이거는 지금 현재 사이트를 만들어서 운행하고 있고요. 그래서 앞에 보셨다시피 이렇게 안에서는 그냥 실습 환경 필요 없이 뭐 프로그램 설치 따로 필요 없이 그냥 순서대로 그러니까 배우는 대로 이렇게 실습을 바로바로 할 수 있고요. 그냥 교육 시스템을 위해서 만든 페이지여서 지금 현재 수업을 하고 있고 거기서 데이터를 모으고 있습니다.
Any other questions? So, what benefits are you trying to find or look for by adding this visualization model?
뭐 교수자 입장에서는 좀 더 공부가 부족한 부분에 대해서 좀 더 자세히 설명을 해줄 수 있고 학습자 입장에서는 약간 자기 거를 좀 더 키우기 위해서 동기부여가 될 수 있는 그런 비주얼라이제이션을 통해서 얻고자 합니다. 네.
데이터가 어떤 종류의
데이터요? 데이터는 학생들이 활동하는 클릭하면서 로그인하고 거기서 실습하고 그 퀴즈를 풀고 뭐 이런 다양한 데이터들이 모여지고 있습니다.
퀴즈를 풀거나 어떤 테스트를 해결할 때 거기서 먹는 시간들이나 그런 해결하는 데 얼마나 걸렸는지 그리고 퀴즈에 대한 내용 콘텐츠들도 다 여러 가지
Any other questions?
Thank you.
Okay, thank you very much.
Good afternoon. Thanks for coming. My presentation is based on partial research analysis in power cable using deep learning. So you have already known deep learning methodology is very much popular and efficient to classify the data in these days. So we are also trying to figure out some methodology to classify partial discharge from the electrical grid system. So what is partial discharge? Partial discharge is electrical discharge or dielectric breakdown between conductors without bridging the conductors completely. So this is usually an anomaly in the system. So our focus in the power cable, because power cable is the most important components in the electrical grid system. So if you look at this picture, this partial discharge is something happened into the insulation, and into the in this picture it is into the joint. So what is the problem when partial discharge occurs? This will happen complete blackout or complete breakdown of the electricity supply. So it has a impact on the social and economic losses. So we need to consider this problem very seriously and try to figure out to solve this problem. So my research question is single specific automatic learning. As it is, we will try to figure out this partial discharge based on the time and frequency domain. So my research question is signal specific automatic learning to differentiate partial discharge and from the noise using the deep learning. In that case, our topology will be like this one. We will collect signal collection from the components like a power cable using the sensors. This may be IP sensors or any other sensors. Then we will feed the data into our model and we analyze the data. So it will be one dimension. This will be an one-dimensional CNN, and we will classify these signals using this model to figure out the noise from the data and classify the partial discharge. So our total pipeline will be data collection and generation. So generation means we will, in the first phase, we will try to figure out this problem using the generated or synthetic data using MATLAB because MATLAB is a little bit very much enriched in the feature for the signal processing purpose. Then we will pre-process this data. We will extract some features and train the features from using the convolutional neural network, then classify it PT and the noise. From the noise. So we will use to classification or for the deep learning model maybe the TensorFlow or PyTorch, because Python is very much feature enriched in the deep learning arena. So this is our system overview and methodology, and we have already did some. We have already done some experiments using the t-SNE visualization. We found that if you use the time and frequency domain data, the partial discharge and the noise will be separated very well. So we think deep learning model will be a good choice for the classifying the partial discharge from the noise. And this all from this if we become successful in this project, we think it will be very much useful to the community for the electrical industry as for the whole society, and it will reduce the maintenance cost. It will qualify the power supply, etc. And that's all my presentation. I would like to take any question if you have. Thank you.
What kind of sensor do you like to use to detect the cable state of cable?
Actually, we nowadays we have three types of sensors. I suppose electrical sensor or acoustics, or for the sound noise detection for acoustic noise, and another is the antenna system. This to figure out the sensors. So it can be used as acoustic, as sometimes sound is a good indicator to figure out the anomaly. Because when a spark occurs in the joint of a cable, then there is a sparking. So sound may be one of the the sensors that uses the sound system. This will be one choice, but actually we didn't yet finalize our sensor parts. We are only focusing on the data analysis and separating the partial discharge data from the noise data. This is our actually main focus. The other side, the electrical engineering parts or the sensor parts, we will discuss the relevant industry so that we can get the data. Actually, our part will be the main analysis from the data that come from the electric grid system or a smart grid system.
Is your input data going to look like the long array where rows stand for elapsed time and columns and individual?
Hi, we are a group of 2 members. Uil and Changbang. Yeah. We have studied spatial data for more than 2 years at the database laboratory. However, the study have focused on not data analysis, but the only database management, such as query processing, data storing, index structure, even though our most works are for data analysis. That's why we take this course now, and we are looking forward to realize the research analytics demands. And furthermore, through this project, we want to develop high quality software and analyze the spatial data. If you see the professor's announcement, you guys know a vast challenge. The title is Mystery at the Wildlife Preserve. And first, what is the visual analytics science and technology challenge? It's an annual contest for advancing the field of visual analytics with competition. This vast challenge consists of 3 mini challenges and a grand challenge. All participants have to solve from only 1 challenge to maximum 4 challenges. If a group solve all 3 mini challenges, they would give a chance to solve a grand challenge. And then this challenge provides some data sets to evaluate their software properly. Okay. Fortunately, this year's vast challenges is very related to spatial data. The title, however, we only focus on mini challenge 1 because we are still a newbie in this field, and it means it will take very long time to make a good service, good software. Okay, the mini challenge 1's title is "Where Have All the Birds Gone?" The mini challenge 1 contains 1 scenario and 1 hypothesis. The scenario is that a PhD student wants to know the reason why certain birds, the number of certain birds decreasing. And his hypothesis is there are some links between traffic going through the preserve and the birds. Okay, the mini challenge 1 consists of very clear, specific 4 questions. The first thing is to describe patterns of life by vehicles traveling through and with the park. We want to discover very repeating or temporal patterns. For example, if a vehicle stays at the same spot and same time every morning for short, we able to think the people maybe drop by for getting a cup of coffee on the way to work. The next thing is finding patterns appeared long times. It means multiple days in this challenge. The third one is unusual patterns. We should find unusual patterns and highlight why we find the patterns. And the last one is very important thing, and that is finding 3 patterns that could be the most impactful to birds. Okay, they provides us some data sets, map images, and trajectory data. The trajectory data contains timestamp, car ID, car type, and gate name. And the image is like this. And actually, we already pre-processed the data sets, and we want to know, and now we want to know just the data set characteristic. So this is not just the result, but just practice to know the dataset's characteristics. So these are two bar charts varying time and months. And this graph is a very interactive graph, which are where the vertex denotes entrance or check-in site, and the edge denotes the link between two vertices. The thickness of the edge represents frequency. Okay, actually, we use a D3 library, not only D3 library, but also some database techniques, and we will make a good software, nice software to support scalability. Okay, that's all of our presentation, and thank you for giving me a chance to talk about our project. Does anyone who have a question or advice include last challenges winner, Professor Chu? Yeah.
Not the only winners, so they
Anyway.
they give multiple awards to the participants. Any questions?
Yes, because we are very newbie. Yes.
다른 세 개라고 하셨 세 개 있는데 그 중에서 이걸 고르신 이유가 있어요?
Actually, I'm not sure, but it's very depend on the special data. Actually, the other main challenges also is related to the special data, but we think this challenge is very related. Yeah.
다른 팀과의 랭킹 같은 건 어떻게
Pardon?
순위를 결정을 해야 될 것 같은데 나중에
예.
어떻게 그게 결정돼요? 평가하는 기준은 혹시
저게 그 아까 퀘스천 있었잖아요. 그 퀘스천에 대해서 답을 저희 지금 PPT랑 도큐먼트 낸 것처럼 도큐먼트 내야 되고 동영상을 찍어서 내야 돼요. 그 사용하는 장면 같은 거 찍어서 그래서 그거 가지고 평가하고 거기서 그 제시하는 질문에 대한 답. 특히 저 사람들은 이제 저 문제에 대한 실제 답을 가지고 있는 거예요. 실제로 저 공원에서 어디 지역에 새들이 줄어들었는지 그거를 저 사람도 알고 있고 우린 그걸 모르는 상태에서 그걸 맞추는 거죠. 패턴 데이터.
Yes.
Is there any way to incorporate any external features? Suppose we are considering local features, but suppose global warming is a reason for the life that very much harmful for the life, or environmental change. Any other? Is there any way to incorporate such features into the system?
They limit the data set. Only we have to use only the set data.
But sometimes pre-trained model or pre-trained framework can be used into the data. Is there any way?
Science is a completely synthetic data. So someone actually spent a lot of time to create this kind of synthetic data. So in that sense, it's a little bit tricky to bring in the external model trained using other data set with the different characteristics.
Thank you.
Okay, thank you very much. So when is the deadline for it? Sure. So July 15th. So it's a kind of annual contest or challenge hosted by this IEEE VAST conference. So it's a quite a fun project, and you basically submit some short paper. Okay, so you basically write your some document or write-up that describes your approach and the findings or answers that you found given those questions, and then it just go through the typical review process. So I myself also work a lot as a reviewer in the VAST challenges, and then I get assigned a few of these submissions as well as the answer sheet for each sub-problems. And then there are some different criteria, just like what you have during this session, like novelty and the correctness of the answer submitted, and so on. And then it's typically composed of 3 different mini challenges. And then after integrating the answers from those challenges, we have a grand challenge. Okay, so 3 mini challenges and then 1 grand challenge. So you can submit all of them, or you can submit one of these mini challenges, or 2, of course. Okay, and for this grand challenge, you have to integrate all these answers or findings from those mini challenges. So in that sense, in that respect, so those teams that participate in grand challenges are composed of maybe at least 5 to 10 students. Yep. And then they among the submissions, maybe about 25% of those submissions will get some award. Okay, so it's not about official publication, but instead you will get some kind of reward as a kind of award for some mini challenges. So they will go through this kind of selection processes, and you will get a nice award paper and so on. It's a quite fun project. I think Okay, so
Hi everyone, my name is Jong-san. I forgot writing the topic in presentation. So the topic is visualizing private spatial store, I think. So I think many of you are unfamiliar with privacy preserving data mining. So this work focuses on while analyzing data, there is a possibility that some sensitive information of data subject can breach. So I think so. One example is a researcher used taxi trip data. So use that data and he tracked the trajectory of some celebrities, I think Bradley Cooper and famous actress Jessica Alba. So there, so to protect this situation, diffusion privacy model is proposed. So this model provides mathematical privacy guarantee. So the mechanism can be summarized like this. So there is a database, and this researcher can be an adversary. So this model takes some query and answer with some noisy answer. So suppose the database has patient information of some certain hospital, and there are 5 AIDS patients, and the researcher knows there are the researcher know every record except one record, and he wants to know whether that owner of that record has AIDS, and so the researcher knows there are 4 AIDS patients in database. And suppose the database return the answer 5, then the researcher will know that that record, owner of that record has AIDS. So to prevent this situation, we differential privacy model add some calibrated noise. So my research topic is applying this differential privacy model to spatial histogram. So, something like this. So my objective is to visualize this noisy histogram. So there is a little work in this field, in this privacy preserving data mining field, on visualizing some kind of this histogram. So I think the visualizing this histogram can be helpful for my future research. So thank you for listening. Any questions?
Any questions?
Your objective is making a visualizing histogram. Then we can choose some parameters.
Yes.
Right.
Okay. The user can throw query and some parameter which is related to privacy guarantee. Yeah. So more privacy guarantee means the smaller data utility, some which is related to query accuracy.
Any other questions? Okay, thank you.